In 360-degree AR-VR collaboration, the telepresence VR user can omnidirectionally view a high-quality 360-degree video immersively. However, unlike 3D reconstruction, 360-degree video lacks spatial information, making it less interactive. Prior work has explored switching between 360-degree video and 3D reconstruction in remote collaboration. However, frequently changing the medium in VR can cause changes in perspective and interactive modalities during collaboration, which impacts continuity and immersion. To give remote users better access in 360-degree telepresence, prior work has proposed attaching the 360-degree camera to a local user. However, besides simulator sickness, transferring the perspective control to the local user diminishes the remote user's freedom to explore the space. It is also possible to mount the camera to a locomotive robot agent, but it is too bulky and costly for regular users. Finally, to interact and collaborate in 360-degree AR/VR collaboration, prior work has implemented pointers and virtual annotations. However, without spatial information, interacting with virtual objects breaks the illusion of physical presence. We present VirtualNexus, a 360-degree remote AR/VR collaborative system with a rich and versatile interaction space. To use our system, the user in the local space wears a Microsoft HoloLens and streams their physical space with a 360-degree camera. The remote user becomes telepresent wearing an Oculus Quest VR headset. The 360-degree camera is attached with a QR code to align the VR world with the physical environment. Our system implements basic collaborative modalities such as synchronized pointers, annotations, and shared virtual objects. We additionally align a hidden spatial mesh with the 360-degree video to preserve the sense of physical presence during the collaboration. This creates an illusion for the VR user that they are interacting the virtual objects with an actual physical environment. With a stationary 360-degree camera setting, the remote VR user cannot move around the streamed environment. Users may find it challenging to access and interact with a further region with ease and precision. In our system, we take the approach of bringing the environment to the users through the environmental cutouts. Users can define a slice of the world that they can interact with and bring closer, for example, a whiteboard. The VR user can move this slice of the whiteboard around and set the cutout active. Now, any object or annotation that the user creates will have two copies, one belonging to the cutout space and one belonging to its corresponding location in world space. The changes in each environment are synced. Environment cutouts allows the VR user to be closer to the selected region of the space. To reflect this, when the cutout is active, the AR user sees the VR avatar where they are relative to the cutout instead of statically at the camera location. For instance, here, they are now in front of the whiteboard. Lastly, our system allows users to incorporate useful physical components from the environment as virtual replicas. The AR user walks around and captures photos of an object, which takes about 15 seconds. We took a futuristic standpoint and implemented a virtual replica creation pipeline with Instant NGP. The images are then processed in a virtual replica creation server, which takes about 1 to 3 minutes. At the end of virtual replica creation, the server sends it to the users so they can create them as shared objects. We illustrate the potential of VirtualNexus through some sample applications. Here, users can use it for virtual authoring and prototyping of digital things. For example, here, we use VirtualNexus to illustrate a story of 3 adventurers traveling through a forest. Secondly, in the education domain, we envision a virtual classroom scenario where a student can use the cutout feature to illustrate on a spatially distant whiteboard. VirtualNexus also allows the teacher to share realistic objects from the classroom by scanning them, for example, this model pig. Finally, VirtualNexus can be used for recreation and games. For example, in this virtual bowling game, the remote and local users can have fun just like they are in a co-located space. To evaluate VirtualNexus, we performed a dyadic user study with 14 total participants. Participants were introduced to the system and tasked to collaboratively create a virtual storyboard for a children's story. Participants used annotations to ideate and integrated virtual objects in developing the storyboard, as shown in the following examples captured from the user studies. Participants used various features of VirtualNexus to create a complete 4-panel storyboard. The novel features of VirtualNexus, mainly the cutout feature and the scanning of real-life objects, were found to be useful in terms of clarity and versatility. Furthermore, participants indicated that VirtualNexus overall offered positive effects towards the feeling of presence and co-location, and lent well towards remote collaboration.